Another beautiful day to bust some myths. Interesting. What am I having for lunch? Wait a minute. I'm sorry, but the old Michelle can't come to the phone right now. Why? Oh, 'cause she's dead. Hi, it's Michelle from Muffin Beauty Science, Chemistry PhD, Skincare Nerd, and Propaganda Source. Today I'm going to be talking about a recent study. It's on the sunscreen ingredient octocrylene turning into benzophenone. According to the paper, benzophenone causes mutations, cancer, and endocrine disruptions. I wasn't going to do a whole thing on this paper because it only really got a lot of attention in France and nowhere else, but then I saw that I was cited in it. Twice. Like and subscribe if you're into sunscreen propaganda, and click the notification bell if you want hot, piping skincare propaganda. So this paper, benzophenone accumulates over time from the degradation of octocrylene in commercial sunscreen products. It's a bit weird. It's open access and I've linked it in the description if you want to give it a read. Let's start by looking at what the researchers actually did. In a science paper, this is in the methods and results sections, and this part is pretty standard. Octocrylene is a pretty common sunscreen ingredient, and under certain conditions it can turn into another chemical called benzophenone, which the paper paints out to be really, really nasty. More on that later. The researchers bought 17 different sunscreens, 3 bottles of each, and 16 of these had octocrylene. They measured the amount of benzophenone in them right after buying them, and then they kept them for 6 weeks at 40 degrees Celsius. In stability testing, this approximates 1 year of normal storage. Then they tested the benzophenone levels again. They found that at the start, there was benzophenone in all of the octocrylene sunscreens, an average of 39 parts per million. There was barely any in the one without octocrylene. After the 6-week storage, they found that the benzophenone went up in all of the octocrylene sunscreens by between 15% and almost 200%. The average was 75 parts per million of benzophenone, and the sunscreen with the highest concentration had 435 parts per million. There are some limitations with this study. The most obvious one is that 6 weeks at 40 degrees Celsius isn't quite the same as 1 year of normal storage. There'll be some reactions that go at 40 degrees Celsius that wouldn't normally go at room temperature. But based on this study, it's probably safe to say that some octocrylene in sunscreens will turn into benzophenone over time. Is this actually a problem? Well, this is the controversial part of this paper. The interpretation of what this means, how the paper tries to put the results into context. This is in the introduction and discussion parts of the paper. If you just read the paper, then it seems like the science is pretty clear. Benzophenone is really dangerous. Snake emoji, snake emoji, snake emoji. The start of the abstract, benzophenone is a mutagen, carcinogen, and endocrine disruptor. In the intro, there's 4 chunky paragraphs on how bad benzophenone is. Benzophenone is associated with a wide range of toxicities, including genotoxicity, carcinogenicity, and endocrine disruption. Benzophenone is an established carcinogen. The problem is, the evidence that the authors cite to show that benzophenone is so incredibly scary, it's mostly in vitro assays, studies in cells, in mice, in guinea pigs, in rats, and zebrafish. Things we're not. This isn't the scientific consensus in humans at all. The authors cite a few reviews on the risks of benzophenone in humans in this paper. These reviews looked at the same evidence, the in vitro and animal studies that the authors looked at, and they came to very different conclusions. The International Agency on Research in Cancer, their report concludes that there's no data in humans, there's no solid explanation for how benzophenone could cause cancer in humans, but because it happened in animals, they can't say whether or not it would also happen in humans. So they basically went, and put benzophenone in group 2B, possibly carcinogenic to humans. This sounds pretty bad, but it means that it missed out on group 1, carcinogenic to humans, and group 2A, probably carcinogenic to humans. Other things in group 2B include lead, progesterone-only contraceptives, mobile phone radiation, and aloe vera extract. It's a mixed bag. So not exactly as strong a stance as you'd think from reading the statements in this paper. They also cite the European Food Safety Authority, who did a safety assessment in 2017. As you'd probably guessed, they were looking at eating benzophenone, which is considered worse than just putting it on your skin. Their conclusions: there is no concern with respect to genotoxicity. The panel concludes that there is no safety concern for benzophenone under the current condition of use as a flavouring substance. Which again doesn't really match what the authors of this study are saying. But it does explain the fact that benzophenone isn't on that EU list of banned ingredients in cosmetics that clean beauty people like to point to. And it also explains the fact that safety assessors already know that there's benzophenone in sunscreens and they're okay with it. Benzophenone is a known contaminant in the octocrylene that gets put into sunscreens. It's actually listed on the safety data sheets from the suppliers. That means that toxicologists do actually consider the benzophenone that you rub onto your skin when they're doing safety assessments for octocrylene sunscreens. Octocrylene is used at 10% max in sunscreens. The highest amount measured in this study is a fair bit higher than 10% of the known benzophenone contamination from popular octocrylene suppliers. But the French Federation of Beauty Enterprises points out that even with the highest benzophenone sunscreen from this study, if you apply 18 grams of sunscreen a day, you still end up with less than half a milligram of benzophenone. This is 3 times less than the maximum allowed dose if you're eating it. So how do the authors explain why their conclusions are so different from the scientific consensus? Well, they kind of just say that the other people are wrong. The risks have been underestimated in both toxicology journal papers and organizational reports. This is unfortunate. Not only that, but the authors say that these other people can be argued to be unjustified and irresponsibly reckless. So all of these scientists who specialize in human toxicology, you can check out their CVs and conflicts of interest on the EFSA website. The EU doesn't mess around when it comes to regulation. They're all wrong, but the authors are right. Let's look at the authors. There are 5 authors. 4 of them are from an ocean research institution. One of them is a human toxicologist, but he's retired and he's not affiliated with any research institutions. But their actual qualifications don't always matter. Maybe they have good evidence. Maybe they reference other authoritative sources that are as qualified and reputable as the IARC and the EFSA, and maybe they say that the body of evidence shows that benzophenone is really dangerous to humans. No, none of the references say this. The evidence that the authors cite, apart from all the in vitro and animal studies that experts with much more expertise have interpreted completely differently, are a court case, lawyers aren't exactly qualified in toxicology, so that doesn't mean much, and supposedly Proposition 65. They say, under the state of California Proposition 65, there is no safe harbor or allowable level of benzophenone contamination in a product. And they say that this reflects the dangers of benzophenone. So this makes it sound like California thinks that benzophenone is so bad that no level should be allowed. That's not how it works. Prop 65 is a law that makes companies put up warning signs about potential toxic chemicals. You might know it from the coffee and potato chips and Disneyland give you cancer signs that went viral a while back. Firstly, this regulation obviously results in a lot of warning signs that don't really mean much in reality. This is because it takes a hazard-based approach, which is what I talked about in my Clean Beauty video. Clean Beauty does the same thing. If something has a potentially dangerous substance in it, then it gets a Prop 65 warning. It doesn't matter what dose you get and how you get it, whether you inhale it or eat it or put it on your skin. These different exposures are pretty darn fundamental when it comes to toxicology. Obviously, injecting a liter of something versus putting half a drop on your skin are going to have very different effects. But that aside, more importantly, no safe harbor in Proposition 65 doesn't mean that something is so bad that no level is allowed. It actually means that they just haven't decided on a safe level yet. There are lots of chemicals that don't have a level and they're slowly being added to Proposition 65. And this makes more sense because if benzophenone was so bad it's never allowed, then grapes would be illegal in California. Grapes naturally have benzophenone in them. The paper also says that 70% of benzophenone that you put on your skin gets absorbed. But if you look at the study that they refer to, it's 70% absorption under occlusion. In other words, 70% absorbs if you apply it and then wrap it up in cling wrap, which is not how we wear sunscreen. The paper does an uncovered absorption as well, and this is a much less scary sounding 44%. It's in the same table, it's right next to 70%. So for some reason, the authors quoted the less relevant measurement. Also, it was done in monkeys. So to me, there seems to be a sort of pattern in how the authors are selecting and presenting the evidence about benzophenone. Now, the authors don't just disagree with the scientific consensus about benzophenone toxicology, they also disagree with dermatologists about sunscreen. The authors imply that dermatologists and marketing propaganda shouldn't be taken seriously when they recommend wearing sunscreen regularly throughout the year and reapplying sunscreen. I don't think I have to point this out, but this is the medical consensus from all of these organizations. And then joining the ranks of people that the authors disagree with, because haters gonna hate, there's me. Apparently, I'm part of various propaganda sources. And while I'm really flattered to be cited not just once, but twice, it's also really bizarre, although maybe not that bizarre in the context of this paper. I'm a YouTuber. I'm not a huge media outlet, and I'm not an academic. I mean, this is me. And the two blog posts that got cited were actually some of the least propagandary of my posts. They were the ones where I talked about the studies that the FDA did that the media reported as sunscreen chemicals soak all the way into your bloodstream, sunscreens seep into your blood. I pointed out that we don't have to freak out about sunscreens and change sunscreens. My sneaky propaganda tactics were quoting actual lines from the study, quoting the FDA who did the study, quoting the editors of the journal that published the study, quoting experts, quoting the American Academy of Dermatology. I guess maybe the authors think that we're all propaganda and we should be listening to the media headlines instead. Maybe this is imposter syndrome talking, but I don't really feel like I'm doing that well at this whole propaganda thing. So why did a bunch of scientists come out with a paper that makes so many unusual claims? I mean, I've read a lot of peer-reviewed papers, but disputing the scientific consensus of cancer organizations and toxicologists and dermatologists without much evidence, and citing a beauty blogger, it's really just a lot in the one paper. Well, I think looking at what else the authors have done gives a bit of insight here. Like I said, 4 of them are from an ocean research institute, and 1 of them used to be a human toxicologist. I think the obvious question is, why didn't they collaborate with an academic who currently works in human toxicology? The only author who specializes in human toxicology on this paper that talks a lot about human toxicology is someone who firstly isn't affiliated with an academic institution, but also he's retired and he doesn't have a PhD. It's weird. I know this sounds elitist, but that's just how scientific academia works. Your first step in your training is getting a PhD. And it's not a one-off either, it's a bit of a pattern in the publication history of the first 2 authors, Craig Downs and Joseph Donato. Craig Downs is the scientist who published and promoted the coral studies that led to the whole reef-safe sunscreen thing in 2018. He's been very active in getting particular chemical sunscreens banned in places like Hawaii. Since then, he's published more studies on how sunscreen impacts aquatic organisms, which is what you'd expect from a marine biologist. But he's also started collaborating with Joseph Donato, author 2, on papers about human toxicology. The only link between these papers and his older work is that they're all about how bad chemical sunscreen is in all sorts of different ways, which is weird. Scientists usually have expertise in a specific field, and they specialize in particular methodologies. They don't jump around different fields focusing on a specific group of chemicals. This publication history doesn't make a lot of sense in my opinion, but if you look at some of the other things that Downs and Donato have said outside of their peer-reviewed publications, then you can sort of see that all roads seem to lead back to chemical sunscreens. Increasing melanoma rates, it's because of too much sunscreen, even though dermatologists and the American Academy of Dermatology and the Skin Cancer Foundation all say that sunscreen can reduce skin cancer. They say that the increasing melanoma rates are because of better detection and different lifestyle habits. Apparently they're wrong. Declining coral reefs?
It's my professional opinion that most of the coral reefs in the last 40 years have died because of your bathroom than anything else. Climate change, oil spills, what have you.
I think this goes without saying, but this is very much not what most coral scientists think. The consensus is that the biggest threats to coral are climate change, ecosystem changes from things like overfishing, and land-based pollution from things like agriculture. There's a recent open access review that looks at all the studies on sunscreen and coral. The measurements that Downs took around Hawaii were 10 to 1,000 times higher than any other published measurements. The conclusion is, organic UV filters do occur in the environment, but according to our analysis, there is limited evidence to suggest that their presence is causing significant harm to coral reefs, although more research should be done. As you might have expected, Donato has said that their lead author was hired by Big Sunscreen. Now, I think there are definitely lots of legitimate criticisms of the beauty and personal care industry, and we can't just trust everything they say. I mean, I talk about marketing myths all the time. But that doesn't mean that the complete opposite of what the industry says is always going to be true. And what are the chances that everyone in the industry and in toxicology, dermatology, and coral science are all in on the same conspiracy to protect Big Sunscreen? People like to blab. In a decades-old conspiracy, there's going to be thousands of people involved. How has no one leaked receipts about all their secret meetings and how people are getting paid off? I think if you have to dispute the scientific consensus in multiple fields to support your theory, including fields that you don't have expertise in, and you don't have strong evidence that other people haven't seen before to support your theory, then maybe it's time to ask yourself if maybe you're being a bit biased. What about the other three authors? I mentioned this before, but one of the weird things about this paper is where it took off. It's a paper in English and the authors are from the US and France. In France, the paper took off almost immediately after it was published. It was all over the media. But in the US, there was barely a blip. This discrepancy is really weird. Skincare people talk about sunscreen all the time, but for everyone else and the media in general, interest in sunscreen is cyclical. There are exceptions, but it's pretty rare for people to care this much about a small study in a country where people mostly just wear sunscreen to the beach, if at all. So what's going on? Here's one suggestion I've seen from French bloggers and beauty experts. If you look at the conflicts of interest section of the paper, that Ocean Research Institute that 4 of the authors work at has partnerships with Pierre Fabre, a huge French cosmetic and pharmaceutical company. A few days after this paper was published, Pierre Fabre announced that they were launching a sunscreen with a new filter called Triasorb, and octocrylene-free features heavily in their marketing. The timing and the hype that was almost entirely isolated to one country does seem a bit suspicious, but Pierre Fabre have denied any involvement. I don't think that a conflict of interest means that the science will automatically be compromised. It's unfortunate, but science is expensive, and a lot of topics just aren't that high up on the priority list for the government to fund them without commercial interest. But it's a bit of a strange juxtaposition with all this stuff in the paper about marketing propaganda and big sunscreen. Another study came out from a Belgian research group at the end of March, and they found that benzophenone increased after octocrylene sunscreens were kept at high temperatures. So again, I don't think the experiment part of this study was wrong, but if you compare the two papers, you can see how differently the two papers contextualize their findings. The other paper mentions that benzophenone is a potential endocrine disruptor and carcinogen, but it really highlights the potential part. There are a bunch of other things I haven't mentioned that to me also seem like pretty big red flags. For example, Donato's public email address for a while was chemicalsaretoxic@gmail.com. Downs' lab runs a program that's a lot like the EWG approved label where they'll certify that your sunscreens are reef-safe for a fee. Last minute edit. Last week, one of the authors from the lab affiliated with Pierre Fabre commented on my coral reef post about adding info on octocrylene being bad. I'm not sure why he's reaching out to someone he called a propaganda source. Seems kinda sus. So, what are the takeaways from this? With octocrylene and benzophenone, the vast majority of scientists don't think that benzophenone is as bad as the paper makes it out to be. But the amount can get higher than expected, although it is still within the margin of safety for oral exposure. So hopefully there'll be a bit more research on how benzophenone affects humans when we put it on our skin, and sunscreen formulators will focus on ways of stabilizing octocrylene. In the meantime, as many skincare experts have said, it's probably still safe to use octocrylene sunscreens as long as you're not allergic to them. But it's safest to not use sunscreens after their use-by date and not expose them to high temperatures, which you are hopefully doing anyway. The wider takeaway is that you can't trust everything you read just because it's in a peer-reviewed paper. This paper had 5 authors who all apparently signed off on this, and there were 4 anonymous reviewers as well. Stuff slips through peer review all the time, especially when it's commentary around the relevance of the research. That part isn't checked anywhere near as thoroughly as the actual experimental part of the paper. Now for some propaganda from Big Learning. If you like poisoning your brain with education, you're going to love this. The first 1,000 to click the link in the description will get a free trial of Skillshare's premium membership. Skillshare is an online community with a massive range of classes on all sorts of propagandary topics like photography, design, video editing, time management. Classes are mostly less than an hour, so you can quickly level up and get those propaganda bucks. I usually use Skillshare to help me make better content for Big Sunscreen, but recently I've been watching a lot of classes about cooking. There's a lot of big, delicious propaganda on there from real-life chefs. I recently took a class to sharpen my knife skills with Elena Karp from Plated, and apparently I was holding my knife wrong the whole time. And now I'm the latest victim of big, not chopping your fingers off. It's less than $10 a month with an annual subscription. Check out the link in the description.